All right, hi stats. This is 12.1 notes, and I think I'm going to do these in three mini little videos so that they're not a longer one to watch. But this is it for notes. This is our last notes for chapter 12. Really straightforward. We're only going over the main basics of 12.1. So let's go. So the first thing we wanted to learn how to do is do a confidence interval on slope of a best fit line. Okay, now typically what they're going to do on an AP test is they're not going to give you the raw data to put into your calculator under lists or anything else. They're just going to give you a printout like the one I've given here. And it says below is a mini tab express output for the regression model using a test score from test 3 to predict the test 4 scores. And they said, let's construct a 95% confidence interval for the slope. All right, so what we remember about our best fit line is that the regression equation is y hat equals a plus bx, right, where b is the slope. All right, so that means that this first line has everything to do with a and the second line has everything to do with b. So if I'm looking at slope, then I am really looking at this number right here. Okay, so in the regression equation right underneath it, they said A is going to be equal to, and we're going to say A is going to be equal to 16.37, and A represents the y-intercept, right? Okay, and then it says, what is B? So B is going to be 0.8034, and that's the one that represents slope. Okay, so if we want to do a confidence interval, we're going to need two things. We're going to need slope, and then we're going to need the standard deviation of the slope. And they're going to call it standard error because we're using our data, not the known population information, but just the stuff we sampled. So they're going to call it standard error instead. So slope, we already know, is 0.8034. And our standard deviation is right here, right next to it. So this is going to be the 0.1360. All right, so we're already halfway done. So this is going to be a t distribution, okay, and it's still going to follow the same idea where we're going to do a point estimate, then plus or minus, then a margin of error. And with this being a t distribution, we're going to start out with our slope, plus or minus our t star, and then we would use that standard error of the slope. Okay, so if they wanted a 95% confidence interval, right? We're going to draw our normal curve. We're going to put our 95 in the center. We're going to figure out how much are left on the ends. This is 0.025. So we're trying to figure out where this t is. So this is going to be inverse t of 0.975, and then it would be degree of freedom equals. So this one has its own formula for degree of freedom as well. This one is degree of freedom is going to be n minus 2. You want to think about it, it's like it's because it's got an x and a y, it's not just minus 1, it's minus 2. So somewhere up there I need to figure out how many test scores they used in this problem, and there it is, they used 26. So my degree of freedom is going to be 26 minus 2, which is 24. Okay, so just like normal, we're going to put this into our calculator. Okay, and we're going to do inverse t, 0.975. Degree of freedom is going to be 24. And that gives us a t star value of 2.0638, right? So we're going to start out with what we know. So we have 0.8034. If you ask me what's the guess of the slope, that's what I would give you. Then we're going to do plus or minus the t star score, and the t star score was 2.06, let's call it 39. 2.0639, and then we're going to multiply it by the standard error. Okay. And if I wanted to do, let's see, how would I go about doing this one? So then I just have to do the add and subtract. And if I do the add and subtract, I would get 0.523 and I'd get 1.084. And that's just manually cranking it out and calculating those two. Okay. So then on to our confidence interval final statement. We are 95% confident that the interval from 0.523 to 1.084 captures the true slope And the true slope is going to be that Greek symbol beta. So this is our parameter. Okay, so remember we're back to confidence intervals. We're using our data sampling as a guess of what we think the true population looks like. And the population parameter here is slope. Okay, a point increases between test 3 and 4. Again, what that means, because we're describing slope, would be for every 1 point increase in test 3, the predicted value of test 4 increases between 0.523 and 1.084. Right, again, that idea being for every increase of 1x, this is our increase of the y, or of the slope. Okay, so I should say of the slope. Okay, all right. Hint, because I was not given the original data on this one, if I try to go and run this on my calculator like we've been doing all along, it is here, and it's right underneath our chi-squared tests. It's two sample, not two sample, it's linear regression, and it's either a t-test or a t-interval, so that's G. If I go and pick that though, it says it wants to see the original data. There's no option to plug in other numbers here. So I really don't have a choice if they give me a computer printout. My calculator is not going to help me. I'm going to have to know how to find t-star on my own, and I'm going to have to go ahead and calculate the confidence interval by adding and subtracting on my own. Cool. All right, that's it for this part. We'll see you for the next one.